Okay, young people, today we are going to be talking about unit conversion. And I'm going to try to make it as simple as I can. I'm also going to try to relate it to your geometry work that you've been doing as well. So let's talk about this. So in geometry, you've been talking about ratios. I know some of you are in algebra too, but you should have had this idea about ratios. And that's what we're talking about here. When we're talking about converting, we're talking about ratios and things that are equal to one another. So in geometry, you learned that ratios are numbers that are equal to one another. And in chemistry, we have to use those ratios to mathematically solve problems. And so we're going to try to begin that process today. So for example, a ratio that you probably are very familiar with is there are 12 inches in 1 foot, or 12 inches colon 1 foot. So I'm writing these in the ways that I know that you learned them in geometry. So you can see how those could be written. And if you look at the bottom where we have these fractions, notice I have a fraction with 12 inches over 1 foot or 1 foot over 12 inches, because you could do them either way. And the way we put them together is really dependent upon what we're trying to solve for. So we're going to get there. All right, so let's look at a problem. So how many inches would there be in 4.34 feet? Now, I'm almost certain that most of you wouldn't have any issue solving this problem pretty quickly, but let's look at the steps that you use to solve them. It's kind of like when you're doing proofs in geometry. I want you to put down your thinking. So we know that we have 4.34 feet, right? And we know that we're looking for the inches. So how do we do that? Well, we have to put feet on the bottom to get rid of feet because it needs to cross out when we do the math. And we put inches on the top. So 12 inches that go on the top, 1 foot goes on the bottom. We do the math now where we cross out feet, feet. Now we do 4.34 times 12 inches divided by 1, and we get 52.1 inches. Now, why is it 52.1? Well, your original number is 4.34. That's three significant figures. Because we have this ratio or conversion factor, that is counted as infinite significant figures. So that has a higher number of significant figures, and the lowest number of significant figures is the 3. So our answer is expressed in 3 significant figures. So let's look at something else. So these are some common conversions that you might need to use. You might want to write these down. Some things that you might be able to think about in the future. There will be others that come along in problems or that come along in things that we do that you will have to write down and integrate into your understanding. But what I'm teaching you today will be used for any kind of conversion, no matter what the ratio might be, okay? So I'll give you a moment. If you need to stop the video at this point and copy this down, please do so. All right, so you already knew that one. You already knew about the inches and feet. So let's talk about a proportion that maybe, or a ratio that you're unfamiliar with. So there are 946 milliliters in 1 quart. You just saw that on the last slide. Or 946 ml colon 1 quart. And we can see how that looks in fraction form. So now that we have the ratio, how do we use it to convert between units? Well, we're going to do the exact same thing that we did with the inches and feet problem. So write the given quantity in unit on the left. So what we do is we take the quantity that we're giving and we write it on the left-hand side of the page. Then we write an equal sign on the right and the unit we're trying to find, because that's going to remind us, hey, what am I looking for? Remember, we're talking about unfamiliar things. And so I'm going to be asking you a long time or during the year to do unfamiliar conversions. So I need you to make sure that you're understanding where we are. Okay, and this is a pretty prescriptive algorithmic method that you can use to solve problems here. After that, you're going to prepare for conversion by drawing the picket fence. The picket fence looks like a football goal, or the crosshairs that you'll see me draw here. Okay, then 3A says write the given unit on the bottom. 3B says write the finding unit on the top. Then I want to look for what's the relationship between those two units. And I'm going to look for that. I can look it up on Google. I can look it up on the things that I have. I can look it up in the question maybe, but there are lots of places that you look for this. In the future, there are going to be some more relationships that you're going to have to understand and know in chemistry. All right, so you have to determine this. And then finally, we can calculate and solve by making sure that we do the math right. It's that simple. So let's look at a problem. Oh, there's the picket fence. Sorry, the picket fence. Okay, so problem 1. How many milliliters are in 3.5 quarts of milk? How many milliliters are in 3.5 quarts of milk? So pretty simple here, right? So we're going to follow the prescription. We're going to follow the method. By the way, if you needed to go back and stop, go back, stop that last slide, copy those things down and make sure you get them, okay? Because that's the method you're going to need. So we know what our given unit is. Our given unit is 3.50 quarts. So we've got our picket fence. We've got our given unit, 3.50 quarts. We're going to do milliliters as our finding unit on the right. Then we have to figure out, okay, what has to go on the bottom? What has to go on the bottom is the given because it's got to cancel out. So quarts has to go on the bottom, so we put that there. Milliliters has to go on the top, we put that there. And we already know the quantity, 946 milliliters in 1 quart. Now we cancel out the quarts because they cancel out. One's on top, one's on bottom, it gets to cancel out. Now we have 3.50 quarts times, or 3.50 times 946 ml, which gives us 3,110 ml. Now that's not what your calculator says. So why did I give that answer? Let's go back for a second. If we look at the original given quantity, the original quantity measured, 3.50 quarts, that has 3 significant figures. So my answer can only be expressed in 3 significant figures. So despite the fact that I got 3,311, I can't express that 1 because it's not, I can't have a significant figure there. So I have to put a 0 as a placeholder. So it's really important that you keep using that idea of significant figures in your calculations as you go. Okay, so let's try another one. So Mrs. Raines is 1.72 meters tall. How many inches is that? Okay, remember, you've copied down that table, so you should have some understanding. So first step is always, now this is going to draw the picket fence, but the first step is always to write down the given quantity in unit. So we have 1.72 meters. So far, so good. All right, then we write down what we're trying to find. We're trying to find how many inches that means. So we see on the right-hand side, we put an equal sign and the unit inches. All right, so what are we gonna do? What's the given quantity? Where does it go? Yeah, it goes on the bottom. So 1 meter goes on the bottom. What goes on the top? Inches go on the top. And we know from a previous slide that we looked at that 39.4 inches are in 1 meter. So now meters can cancel out. And now it's just a math problem. 1.72 times 39.4 divided by 1. And we get 67.8 inches. 67.8 inches. Okay, so let's try another one. Practice 3. Mrs. Raines purchased a packet of chopped pecans that had a mass of 1.5 pounds. How many kilograms is that? So again, this is the same idea that we've been working on, right? So what do we know? We know 1.5 pounds. We're going to write that down as the given quantity on the left. Then we're going to write an equal sign with kilograms because that's what we're looking for. Now our process says, okay, we've got our picket fence, we've got our given quantity in unit, we've got our finding unit, we know what we're looking for. Now we need to find the relationship and we need to know where to put these things. So the given unit goes on the bottom, pounds goes on the bottom, kilograms goes on the top. Then we look for the relationship, 1 to 2.2. So 1 kilogram to 2.2 pounds. So notice 1 doesn't always have to be on the bottom. It can be on the top too. It's according to what you're given and what you're finding. So you have to use that kind of idea. Given unit, finding unit. And if you can use that idea, it makes life so much easier. Okay, we cancel out pounds because one's on top, one's on the bottom. Now it's the math. 1.5 times 1 divided by 2.2, and we get 0.68 kilograms. Why only two significant figures? Yeah, 1.5 pounds only has two significant figures, so my answer can only be expressed to two significant figures. So I want to talk to you a little bit about metric prefixes. Now, I've already taught you how to do this. We already know how to do this. However, I want you to make sure that you understand that there's conversion at the heart of this. So what I've done is I've given you a table that has the base unit as 1 and gives you the equivalence of all of the other units to the base unit being 1. So if we look at this, we can see that 1 liter is equal to 1,000 milliliters. Okay, 1 liter is equal to 1,000 milliliters. I'm going to get to that other one in just a second. Okay, another one that we can look at, and another example that we can look at is a bigger example. So example 2 says 1 meter is equal to 0.01 hectometers. Now you guys don't like those. So you can also think about it in a different way. So you can see it says, or 100 meters is equal to 1 hectometer. I was trying to give you a table that you could find equivalents for everything, that everything was equal to the 1. Okay, so you have a way to do that and think about it. It's all about ratios. But remember, you have another way to do problems like this. And if that's the way you want to do it, that's fine. But I need you to make sure that you understand that this is the math of it. There is math here. There are relationships and ratios here at play. It's not simply just I'm moving a decimal point randomly. So make sure that you understand that. So let's do a problem that may involve something like this. All right, so we just did a problem on the purchase package of pecans, and we found out how many kilograms that was. So now, how many grams is that? So let's look at it. So we know that it's 0.68 kilograms. That's our given quantity unit. That's from the problem before. And we know that we're looking for grams. So in that case, kilograms has to go on the bottom, grams has to go on the top. And if I look at my little chart that I made, it's 1 gram to 0.001 kilograms. So we keep going. Okay, kilograms cancel out. Now we have 0.68 times 1 divided by 0.001. And we get an answer of, that's not right. I didn't change it. It's 680. Sorry about that. I did not change that. It should be 680. It should not be 0.68. Please change that right now. 680. So, or we could look at it like this. And again, the answer's wrong because I didn't change it. We could look at it from the perspective of, instead of having a decimal number for kilograms, looking at 1,000 grams. These are the same thing. And the answer should be 680. Please make sure you change that. Now, having said that, you know this method. What if we had 0.68 kilograms? Well, you know King Henry died unexpectedly drinking chocolate milk. So there's 1, 2, 3 jumps to get to the base unit of grams. So we have 1, 2, 3 jumps. There's an empty spot, so we have to put a 0 in it. So we know that 0.68 kilograms is equal to 680 grams. So hopefully, even though I messed up that last slide, you have the idea that you can do things in many different ways. But the metric system, you have different ways for. But the other conversions that you're going to have to do and have to practice, I really need you to practice it the way that I've given it to you so that you can get those things correct. All right, so we're pretty much done with this particular thing.